Lappeenranta University of Technology has considerable experience and expertise in nuclear thermal hydraulic research. Driven primarily by domestic needs, the Nuclear Research Laboratory has been studying thermal hydraulic behaviour of nuclear power plants since 1975. This video gives a brief overview of some of the test facilities that can be found at LUT. Safe operation of nuclear facilities poses a number of challenges. In nuclear power plants, the three fundamental safety functions are control of the reactivity in the reactor core, removal of heat from the fuel, and confinement of radioactivity inside the nuclear power plant. The physical barriers that keep the radioactivity inside the nuclear power plant are the fuel matrix, the fuel rod cladding, the reactor pressure vessel plus primary circuit, and the containment system. All these barriers are modelled in the test facilities of the Nuclear Research Laboratory at LUT. Nuclear thermal hydraulic research is needed for the design and optimization of nuclear reactor fuel and nuclear reactor components. Better understanding of fluid dynamics and heat transfer phenomena improves the safety and reliability of nuclear reactors and helps prevent accidents like those at 3 Mile Island, Chernobyl, and, most recently, Fukushima. The results of thermal hydraulic experiments are used for validation of the computer codes that model the behavior of nuclear power plants. Validation ensures that real plant calculations can be performed to acceptable accuracy. When it was constructed, the main objective of the re-wet test facility was to investigate the fuel rod re-wetting process and derive heat transfer coefficient values for heat transfer from the rod surface to the coolant. The effect of nitrogen dissolved in the coolant was also studied. The facility is now used only for demonstrations and student work. The re-wet test facility has 3 rods in the core with a total heated length of 1.5 meters. The transparent tube surrounding the rods allows the re-wetting phenomenon to be easily observed. The maximum heating power of one rod is 2000 watt, and the initial cladding temperature at the beginning of reflood is between 300 and 900 degrees Celsius. The temperature of the injected coolant can be varied from 20 to 80 degrees Celsius. The PWR Pactel test facility has been designed and constructed to model the thermal hydraulics of an EPR-type pressurized water reactor. A significant aspect of the design of the facility is the use of some parts from the original Pactel facility, which is used to simulate the behavior of the Soviet-designed VVER-440 pressurized water reactors currently in use in Loviisa, Finland. The PWR Pactel test facility comprises a reactor pressure vessel model, 2 primary circuit loops with vertical steam generators, a pressurizer, and emergency core cooling systems. PWR Pactel experiments aim, in particular, to gain experience of the thermal hydraulic behavior of the EPR primary circuit, especially the steam generators. The P-Poolex test facility models a boiling water reactor's containment system and is used for condensation studies. The main component of the test facility is the approximately 7.5 meter high cylindrical test vessel. The facility has dry well and wet well compartments separated by an intermediate floor. Gas is directed from the dry well to the wet well by a vertical blow-down pipe attached underneath the floor. The vessel sections modelling the dry well and wet well are volumetrically scaled based on the containment systems of the two boiling water reactors at the Olkiluoto plant in Finland. The test facility is able to withstand the considerable structural loads caused by rapid condensation of steam. The HYPE test facility is designed to study two-phase flows in an inclined pipe and to support experimental research on advanced measurement techniques such as particle image velocimetry and the use of wire mesh sensors. The test facility consists of a transparent pipe section, a water storage tank and piping. The pipe section is made of acrylic pipe with an inside diameter of 50 millimeters, and the alignment of the section can be freely changed between vertical and horizontal. HYPE is the first test facility in Finland with wire mesh sensors. There are two cross-sectional wire mesh sensors which measure the void fraction distribution of the pipe cross-section, and an axial wire mesh sensor which measures the development of the two-phase flow in the axial direction. Safety is paramount in nuclear power plants, and both computational and experimental thermal hydraulic research is needed. Lappeenranta University of Technology is contributing to safe nuclear power now and in the future.